All right, more limits with square roots, and this is where students begin to realize that their algebra skills are vastly unsuited for calculus work. Probably about, 75% of my students have very weak algebra skills, simple algebra, believe it or not. They just cannot handle square roots. They just can't handle computation with paper and pencil. They just are pathetically weak when it comes to algebra. Here's a perfect example. I'm going to show you where my students fail almost all the time. The limit as x goes to infinity, the square root of x squared plus x plus 3 minus the square root of x squared plus 5x minus 1. Students will simply try and put infinity minus infinity like they're numbers. Like infinity is a number. They'll subtract infinity minus infinity to get a number. I don't know what school even teaches that kind of idiocy, but my students all the time, they put that kind of stuff, and it's wrong. It is wrong. It is wrong. It is wrong. Infinity minus infinity is wrong. So how do you actually do this problem? Well, you have to have some algebraic skills. So let me rewrite the limit as x goes to infinity, the square root of x squared plus x plus 1 plus 3 minus the square root of x squared plus 5x minus 1. Now, probably the easiest way I've seen to do these things is to multiply by the conjugate. If you have the square root of something minus the square root of something, the conjugate is the square root of something plus the square root of something. So that's what I'm going to do. I'm going to multiply the numerator and denominator of this expression. You can think of it as a fraction if you think of it all as being over 1. I'm going to multiply the entire thing by the fraction of conjugates. Numerator x squared plus x plus 3 plus square root x squared plus 5x minus 1. All of that is divided by itself. So technically I'm multiplying the whole expression just by 1. However, the numerator is a difference of squares. I have an a minus b times an a plus b. The denominator is just going to be 1 times the sum of the square roots. So using the difference of squares formula, the top becomes x squared plus x plus 3 minus x squared plus 5x minus 1. Don't forget to put parentheses around the x squared plus 5x minus 1. Even when my students know the trick, they still cannot grasp the importance of parentheses. So the denominator will have x squared, the square root of x squared plus x plus 3 plus the square root of x squared plus 5x minus 1. Now, let me simplify the numerator. You'll notice that the x squareds cancel out, and it looks like I'll have the limit as x goes to infinity. The x squareds cancel. It looks like negative 4x plus 4. In the denominator, I'm not doing anything with it just now, so I'll still leave it as the conjugate expression. I'll need to increase my vinculum to accept how large the denominator is. Now, what I'm going to do, in the numerator, I'm going to factor out x. So what's left in the numerator is negative 4 plus 4 over x. Now the denominator, inside of the square roots, I'm going to factor out an x squared. So in the first square root, that will leave me with 1 plus 1 over x plus 3 over x squared. That should be over x squared. I'll fix that in a minute. I've written earlier, but I'm recording later. So x squared for the second one, we have x squared. If I factor that out, that'll leave me with 1 plus 5 over x minus 1 over x squared. Okay, let me see if I fix that piece now. It should be a 3 over, there it is. Okay, now when I pull the x squareds out of the square root, another basic algebra feature, When you factor out an x squared from a square root, it's not just x, it is the absolute value of x. So I'll leave the numerator as x times negative 4 plus 4 over x. But the denominator, I'll pull out my absolute value of x, and inside of the square root I have 1 plus 1 over x plus 3 over x squared. And in the other piece, I have the absolute value of x times the square root of 1 plus 5 over x minus 1 over x squared. Now, since x is going to positive infinity, x is guaranteed to be a positive number. The absolute value of a positive number is that number itself. So I can simply, and if you're the type that you don't understand why it's the absolute value and you just went to this stage where you changed all the absolute value of x's to x's, you just lucked out. Absolutely, positively lucked out. The only reason why it's positive, it's just x and not why I could just drop the absolute value is because that x was positive. So I'm going to factor out an x out of the entire denominator. Once again, increasing my division bar vinculum. So cancel the x's. Now I'm in a stage where I can just plug the infinity in. That means the 4 over x becomes 0. Anything that is over x or over x squared becomes 0. So I have negative 4 plus 0 in the numerator, and that's divided by the square root of 1 plus 0 plus 0 plus the square root of 1 plus 0 minus 0. This all works out to negative 4 over 2, which is negative 2. And like all the other problems, I'm going to do a check with the calculator to make sure that I did everything correctly. So let me go in and put into y1 the expression that I was taking the limit of. Clear whatever you got there. Then let's insert the square root of x squared plus x plus 3. Now move out from under the square root so I can start the next thing. Minus the square root of x squared plus 5x minus 1. And as before, I'm not going to bother graphing it. I'm just going to go straight to the table. I'll start my table off at 10,000, and I'll also increment it by 10,000 as well. So let's take a look at the table values and see what we got. And from this you can see it's pretty obvious. For all my huge values of x, all my y values are getting closer and closer to negative 2. In fact, the display is so limited that it just writes negative 2. But to me, this is evidence to suggest that I did the problem right. So let me go ahead and copy and paste that in. Of course, just stretching it out so you can see what I'm talking about. I mean, basically the whole screen to me indicates that the limit is negative 2. So this checks with what I did by hand. Now, I've decided to do this same problem again, but this time I'm going to let x go to negative infinity. And now, if you're the type of person that does not understand the absolute value and what to do with it, this is where you will be destroyed. Let's have the limit as x goes to negative infinity of the square root of x squared plus x plus 3 minus the square root of x squared plus 5x minus 1. Alright, so I'm going to grab something that I had before, one of the earlier ones. Actually, the previous problem. Let me just lasso some stuff. I've circled the absolute value of x because they're going to be key to what we're going to do here. So let me copy this section and paste it. The section where I had the absolute values involved. So throw it below. But an interesting thing about this program is it comes out really thick, like I've used a Sharpie. You can see it there. But anyways, the only thing that's different about what we're doing now is that x is going to negative infinity, not to positive infinity. So let me erase that piece off. So change it, x going to negative infinity. And then since x is going to negative infinity, x is guaranteed to be a negative number. Thus, the absolute value of x is equal to negative x. The absolute value of a negative number is the negative of that number. That's how it makes it positive. So wherever I see the absolute value of x, I'm going to change it to negative x. So you can see this is what makes the big deal when you are going to negative infinity versus positive infinity. This is where you have to know how to deal with the absolute value of x. Unfortunately, as I've tried to warn you, most students take it as some sort of a joke, I think, not like a real function or something like that. Anyways, let's get the parentheses finished up. Now when I cancel the x's don't completely cancel. I have a -1 factor in the denominator, so now I'll go right to the answer. The limit of -4 is -4, but the limit of 4 over x is 0. Don't forget that -1 down there. Then we have the square root of 1 plus 0 plus 0 plus the square root of 1 plus 0 minus 0. And now this is similar to before. We end up with -4 in the numerator. In the denominator we have -1 times 2, and the answer is now +2.